Okay, guys. Okay, so switching, we need to start the switching as we discussed. So very important concept, guys. Switching is not is a very important concept for any network. So we will be discussing here what is layer 2 switching, switching services, bridges versus switches, tree functions, table, MAC table, switches loop as well, spanning tree. So layer 2 switching. Number one, what is the purpose of layer 2 switching? Break up the collision domain. That's what this is. Okay, I'm not doing it. So purpose of the using the switching, break up the collision domain. Discuss. You got it? You got this point? How we can break up the collision domain? Yeah. Okay. Cost effective, resilient, right? And also it provides you spanning tree. Okay, we'll come back. So as you can see, this is layer 2 switching. There are a lot of hubs are connected to the router, and we have all sort of typical switches design. As you can see, mostly, for example, in this floor of building, this company, for example, they have a different switches. There's a data link, data port connecting here, and they are all going to the switches network. And okay, so each floor might they have their own. Resuming recording. Okay, guys. So please on the board. So everybody, please on the board. Okay, switch. So switches, the problem with the switches, switches do not break the broadcast domain. It is only router who break the broadcast domain. This is the difference between bridges versus LAN switches. Bridges are software based, while switches and hardware, and because they have used ASIC chip to help them to make filtering decision. A switch can be viewed as a multi-port bridge. Bridge can be also have one spanning tree instance. Switch has a higher number of ports than bridges. Both bridges and switches. So sometimes bridges and switches, it's like an interchangeable term, right? Bridge and switch, not a lot of difference. The main difference may be bridges are software based and switches are hardware based. So of course they are more efficient. They're more, they can provide you more connective. Both bridges and switches forward layer 2. Bridges and switches learn the MAC addresses. Both bridges and switches make the forward to the layer 2. Yes. Yeah, they're faster. They are faster than the bridges. That's the reason. Okay, what is the main reason for switches? What? Guys, okay, that's very important. How the switches are learning, how they're forwarding. So number one, what is the main job? So what is the main job of switches? They are learning the addresses, they are forwarding it, and they are trying to avoid any loop. That is very, very important and very tricky concept, guys. This is where our lab will be starting. Okay. Layer 2 switches and bridges, remember the source at hardware addresses. Let's just go into the next slide, and that will be better. So initially, when you turn on the switch, there's a host A, B, C. They are connected to different ports of switches. And E, for example, this is connected to A, E0, this is connected to E0. They are different ports, and they are connected to different switches. We have 4 PC. Initially, when the switch comes up on the network, you turn it on, empty. Nothing is there. The MAC table or the forwarding table is empty. The switch learn all the MAC addresses. Router know the IP address. Router is a layer 3 device, switch is a layer 2 device. So what happened? The slide is missing. What happened? I can tell you from here Let's say the switch router A, so it host A, send a message to host D. Okay, that message, what will be happening to this message? Tell me, guys, initially. Yeah. 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 Okay. Hold on. I'm not at the switches level. Switches level. Right? Yeah. Okay. Yeah. Anybody? Okay. Let me just explain. Anybody else would like to add anything? He's writing somewhere, but a few things. Perfect. Good. Thank you. So, because it's the first time communication, which does not know about A, B, C, D, the MAC table is empty. There's nothing on the network. Nobody's talking to each other. Very silent network. But when at this point as A send the message to D, it will be broadcasted to B, C, and D. And once D receives that message, oh, it's because of the D, the other people will just discard it. They're not interested. They will not send reply back to A. But in this broadcast message, one thing happened. Switch now learned that the A is connecting to port E00 and D is connecting to 03. You got it? Now both the parties reply back with their MAC addresses, which say, oh, these guys are connected to this market. So every day, let's say you go to the office in the morning, you see your neighbor, this neighbor, what kind of his face, what type of his car, you know by name. Also, not maybe you don't know by name, but you know maybe what's his face and maybe his car or some other symptom. Mr. XYZ, short, whatever it is, he's coming from this house. Initially, when you were on the street, you came into the new street, you don't know who is living. So you only start discovering who is coming from this door, who is coming from this door. Broadcast is not a good idea. However, the broadcast, at least what we've done is, through the broadcast, we learn who is living there. This is the way which learn the MAC addresses in the MAC table through this. So let's say I'm going to the please come on, let guys get the get your packet tracer in front of you, and you will be doing the lab with me. Very quick. Switches. We need a switch. Let's say I'm going to go for this switch. 2 switches right now. Done? Yeah, 2 switches. And let's take 2 PC as well. Okay. And which cable I need will be connected? Straight through or crossover? Are you sure? Yeah, from here to here. Yeah, just use any 1 0 on the switch side, and also just use 1 PC at the moment. Yeah. Okay. Then switches need to be connected. Switches will be connected through crossover, and I'm connecting with the port 23 to port 23 on this side. Similarly, I'm connecting 1 more PC to the start using this, using that. Very simple topology. Everybody's following, guys? Ruby? Please, I need some feedback. I need some acknowledgement, guys. I'm a TCP. I'm not UDP. I'm just, okay, I want participation in the class. I want everybody to wake up. Nobody's allowed to sleep here. Yeah, you had enough sleep last night. I didn't have it. I'm just talking. Anyway, what happened? Now, what you do, okay, in this switch network, we have not connected any router yet. We just connected to PC with the switches. What will happen? Just go into the switch now. and I'm just naming this switch as a switch 1. Save. Switch 2. Switch 2. Save. Okay. Now, when I go there, now you can see all the links are green. When I go into the switches, actually, you typing this command. Yeah. Just show MAC address table. Show. No, not at the moment. Just for the time being, nothing. So you can see show MAC address table. Yeah, on the any of the switch. Similarly on here, on the CLI MAC address table. So what happened? What switch has learned so far, guys? Yeah. So you can see the port 23 and 23. How we can know that which port is connected? We can write it. Yesterday he done that. Yeah. How can I know? Oh, this is, yeah, this is here. Here we go. So you can see 23 and 23. This 23 and 23, they both are up between the two switches. They are green. And when you see that, they have learned the MAC address. They have learned the MAC address from one switch to another switch. Yeah. If you want to see the MAC address of the switch one, you can see this command, show interface fast 0/23, and you will see this MAC address. That is the MAC address on the switch. And that will be learned by the other side, 17. If you go this side, you see the 17. And this side is D17. So these two MAC addresses are learned by the switches. They're keeping in their CAM table or CAM table or MAC table. On the top of my head, what is CAM? I think access memory something. Yes, CAM table. CAM table is like MAC table. Or it can be the MAC table or CAM table. Both terms are fine. Okay. So now switches learn the MAC address, but switch has not learned the MAC address of this PC and this PC. Why? They're not communicating to each other, isn't it? Yeah? They're not communicating to each other. Okay? Even though the port is up, if you do this, show interface, show IP interface brief on the switch, you see the port 11 is up, which is connecting to my this PC. Yeah? This is up, and also show IP interface brief, the port 1 is up. But when you see the MAC table, it's empty. Is empty. Clear? So let's say I'm going to assign (24). I'm assigning an IP address. Everybody know how to assign the IP address to the your PC? Click. Yeah. Yeah. Go to the PC. Go to click to the PC. Configure. You don't need anything like that. At the moment, don't. Yeah. No gateway, no gateway. Just IP address. Just an IP address. Public. Come on, guys. We need to do a lot, and I need to leave at 1 o'clock. So Aslan will be here. He will be doing that. But before that, we need to cover a few things. You will be getting a break at 1 o'clock. No break before that. If you need 5 minutes break, but for water, that is only possible. Anyway, are you here with me? Find the IP. 10.1.1.1 on one side with the default subnet mask. That's fine as well. That's a class B, class A network mask. Okay. Anyway, that's okay. That's fine. So let me just do that as well. You know, to keep it consistent. Without a no need of a gateway. We're not jumping to another side. Okay. Okay, done? IP address is done. So now have a look. What happened? Show MAC address. Show MAC address. What happened? Because the port is up now. As soon as you assign the IP address, send some message to the network. Yeah. 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 So you can see I'm pinging to the other side now. On the PC1, one prompt, IP config. IP config will tell you what is the IP address you have configured. And you can see there is no default gateway. Default gateway you only need if you want to cross one boundary to another boundary. Maybe 10.10.2 ping into 8.8 or 5.5. If you are using the same network, as long as you have correct subnet mask, you are able to configure. So you can see my IP is 10.1.1 and I'm going to ping .10.1.1.2. Everybody is working? Ruby? Good? Kevin? Okay. Okay. Now, this is how the switches are learning. Switches are learning is now switch discovered with a fast 00. I have this MAC address. Okay. Keep in mind the Cisco write the MAC address in different format. It's like 2 bytes, 2 bytes, 2 bytes, total 6 bytes. But when you come into the PC and you type this command, ipconfig all, you see this is the MAC address B20, 0B20. And on the switch side, you see this 0B20. But you see the difference. I think that is also writing in Cisco. Yeah, that's fine. Yeah, the 0B20. Maybe B is smaller or lower, it doesn't matter, but you can see the B. Yeah. 6 bytes, 6 bytes, 6 bytes. So you discover that fast 00. Okay. Similarly, if you do one more PC, okay, you want to create another PC and you connect the cable. Which cable you need, guys? Straight through? Yeah. And I'm connecting this to fast 02. Okay, we'll do the IP as well. Just 1 second. You see that IP show MAC address. There is no table. There's nothing here. Okay. But you can assign the IP address to this guy as a, you can assign the IP address to this 10.1.1.3. Make sure no duplicate. Once you assign that, you will see Now you see that straight away, and this link is green now. Yeah, just assign the IP address to this. No, because the link is, as soon as it comes up, it's sending some messages. Yeah, normally it mm, yeah. Guys, save this lab. I saved it myself. If you're home, you can practice, right? Okay. So everybody knows how the switches are learning the MAC addresses. It just find the who is connected to which port and learn the MAC addresses from there on. And you can see that if you go to the this switch, second switch, it only learned the MAC address of 17, which I believe this guy. Now you see, switch learn the MAC addresses on the switch B. I learned 3 MAC addresses. See? I learned 3 MAC addresses on the port 5 F023. They are coming from here. When I ping from this host, look at that. This host back to these hosts, now I'm learning the MAC address here. Previously, they were not in my table, as you can see here. When I ping initiate a communication, 100.1.1, 100.3, you see that now the switch has learned the MAC address. All clear? 3 MAC address. Okay, have you pinged them? How many MAC addresses you can see? How many MAC addresses you can see? How many MAC addresses you can see? Okay, that's enough. Okay. That's the guys switching concept, how the normally switches are learning the MAC address. Yeah, you disable it, it will goes away. For what? No, go to the port and shut it down. Yeah, so you go to the port, for example here, interface F01, say shut. Yeah. Yeah, you see that that port is down now. You as soon as you've done that, this is guys where you can configure your duplex setting. Duplex in the go into the interface far 0/1, say duplex half full auto. Okay, mostly it's auto. If you say half full, we discuss about that. Auto will negotiate with the switch or router or device, and it automatically detect that. But for example, if you want to see that, show interface F0/1, here you will see the information. You see the duplex, full duplex 100 megabits. That interface is operating in the full duplex and 100 megabits per second because fast Ethernet is 100 megabits per second. Oh, shit. Okay, guys, at the moment, you look at this is a orange sign and green. This port is green, and you can see it's taking a lot of time. Actually, the port is going to be turning into the green. Even I thought I unshut the port. And you will see the reason in a couple of minutes, not in a couple of minutes, at least 15-20 minutes. Okay, now you see the code is up now. So I save this topology later on if you want to practice at anything. So now guys, the next topic, that's a very important topic. This is called a topic called spanning tree, STP. That's the most important topic in CCNA, the most difficult topic in CCNA. Spanning tree and the concept of subnetting and VLSM is the most important and most difficult topic. So I try to make it very simple. I don't want to send across so many slides to you. Okay. So guys, tell me, do you ever experienced anything where you find that you are going to one of your friend house, a family friend house, or anyone, and you found that you can't find his address? What happened? What happened normally? You're searching his house on the car, going in circling again and again and again, you know, and suddenly maybe you. Yeah. Exactly. But just in case, maybe when back days when there was no navigation or you're following some kind of books, maps. Yeah, fine. But the problem is, I'm just discussing here. So the issue is here, I'm just trying to discuss, you lost actually, or maybe you're just going in a circle and circle and circle again, creating kind of undesirable things. Okay, so now in the layer 2, there's a problem. In the layer 2 network, there is a one problem. Okay, the layer 2 has a problem. It does not have a loop prevention mechanism. What do you mean by loop? When you send an information, sorry, second? No, it's not that. Duplicate IP is different. So loop prevention is different. So for example, as I said, give you just an example. If you could not find a house, let me